Only 9 pupils, 8 pupils are there. Okay? You're getting my voice? Tell me yes or no. You are getting my voice or not?
Sure. Yes.
Yes, you're getting. आवाज आ रही है ना? Yes, you're getting my voice now? Okay.
तो पर आपकी वीडियो ऐसा ब्रेक हो रही है बीच बीच में।
Yes, what you saying? Yes.
आपकी वीडियो बीच बीच में ब्रेक हो रही है।
बीच बीच में क्या?
ब्रेक
आवाज
हो रही
कटता
है
है
सर।
ना?
हाँ हाँ।
Hello. The voice get breaks ना?
हाँ सर, मैं वही बोल रहा हूँ।
अच्छा ठीक है। सबका स्पीकर ऑफ है। ठीक है। Now today we'll take the what last time we're studying the different what is the so in the moving an instrument is used to measure AC and DC voltage and current. Okay, there are two types of moving an instrument. One is the one attraction type moving an instrument and the repulsion type moving iron instrument. So one by one we'll see the attraction type and after that we'll see the repulsion type. So see the diagram. Okay, मैं diagram draw करता हूँ. आप लोग diagram draw करो, right? Attraction type. Okay. Equal parts and that point is there. The point is divided into equal parts. Okay, this one, this is half portion of the coin is upper side. Okay, coin is what? This coin. Upper upper portion, lower portion. Okay. Now this file, okay, this is what magnetic core. It has magnetic core. No magnetic core here. And here we keep what file. File what of that? This is of copper winding. Using copper winding. They don't copper winding. Okay. Now in this what happened? So when we keep this water here, okay, then our magnetic field is produced. The magnetic lines of flux. One is somehow one in this direction. This field is there. Hello. 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 हाँ. टाइप की सेगमेंट अप्रूव तो नहीं मांगता, लेकिन उसमें हमने की भी है। इसी तरह कुछ नॉन्स की वेरिफिकेशन हम कर रहे होते हैं। मेरा ख्याल है ये भी हमें नहीं चाहिए होगा, अगर डीएस के पीछे है ना, बस फॉलो दिखा। ठीक है, तो ये वाली डायमेंशन मेरा ख्याल है जो सीरीज के अंदर अवेलेबल है, और जो हमारी लोकल ग्रुप पे होती है वो तो हमने नंबर 1 मैप कर दी है।
लेक्चर लो
और
चल
ये
रहा
इसी
है।
तरीके से ना डिजाइन में भी रिफ्लेक्ट हो जानी चाहिए। हम स्पेसिफिकली बता रहे हो कि हम ये भी
ठीक है,
सिर्फ मैप कर रहे हैं ग्रुप रिपोर्टिंग की।
और
और नंबर
लेक्चर चालू किया आपने?
होगा ना, तो इनकी इनपुट कहाँ कहाँ से आ रही होगी वो भी एड्रेस करने की जरूरत है। फॉर एग्जांपल मैं तो कह रहा हूँ सिर्फ मोमेंट की मैं बात करूँ, अगर मोमेंट की यहाँ पे एक लाइन है ना, लेकिन
का
वो एक
नाम
बहुत
किधर आ रहा है?
कॉम्प्लेक्स वो है। मैं जैसे मोकॉर्ड में मैंने आपको मूवमेंट की डायमेंशन दिखाई थी, वो मेरी कलेक्शन, पेमेंट, एक्रूअल, एफएक्सपीएल और मल्टीपल एग्जैक्टली
पता
जिसकी
नहीं
बेसिस पे
ये
मैं
इसको
कैश फ्लो बना रहा हूँ। तो इतनी की आपकी वो आ रही है कि हमें काइंड ऑफ मूवमेंट मेंबर्स ही बनेंगे उसकी, वो तो हमारे बनेंगे ही बनेंगे। अच्छे से students, sorry for disturbance. Okay. Now listen to it. So this is a diagram of the moving attraction type moving on instrument. So this is the coil. Okay. So this is the coil. This is the coil. Okay. Coil or it's called coil. It's called coil winding. Coil winding. This coil is one two parts. The hollow portion is free to rotate the shaft. Okay. Now this is the pointer. This is called a pointer. You know this is called pointer. This is the scale. Okay. This is the what? Connecting weight. Oh, this is called moving iron. This is called moving iron. Okay. Moving iron. This is called connecting weight. Okay. Connecting weight. Okay. This is connecting weight. Okay. Once you are using gravity control, this is what air friction. This is what air friction. Air. Means in this instrument, we are using the what which controlling system? Gravity control system. What is gravity control? Friction concept is क्या? Damping, air friction damping. What is that? Air friction damping. Control is what? Gravity. What is what? Gravity control. Okay. Understand? So this is the free. This is what attraction type moving iron instrument. This moving iron is free to rotate in these two hollow coil. One hollow coil is there. In that coil, we keep the one iron disc to free to rotate. As the magnetic field produced, it will deflect. When it will deflect, the pointer will move. The pointer will control by this controlling weight. And the damping will get by with this air friction damping. Okay. So this is all about the construction of what? Attraction type moving iron instrument. Okay. So I'm explaining now just for you to see the construction. What is the construction diagram? Diagram is very important. और आपको हमेशा 12th में 11th में पूछते हैं और this diagram is on the piece is also more than the deflection of depends upon the strength of the current passing through the path. जैसे कि अभी करंट कम रहेगा, the attraction will be less. ऐसा कम इसको अगर the strength of the current is less, the magnetic field strength is very less, so it will attract by small distance. The torque produced in this coil is very less. When the torque is produced in this coil, then it will give a very slow deflection. Okay, this is a less amount of less current. The current is more, then it will deflect in large scale. More current is there. Understand? The less current रहेगा, it will deflect very less distance. More current will deflect more distance. ज्यादा deflect होगा तो pointer ज्यादा स्केल पे जाएगा, कम डिफलेक्ट होगा तो पॉइंटर कम जगह आएगा. इज राइट. इनिशियली द पॉइंटर इज एट 0. अगर स्ट्रेंथ ज्यादा कम आएगा तो पॉइंटर कम घूमेगा. अगर ज्यादा अंदर आएगा तो पॉइंटर जितना कॉइल ज्यादा अंदर जाएगा उतना पॉइंटर को क्या क्या डिफ्लेक्टिंग फोर्स ज्यादा मिलेगा और पॉइंटर विल मूव. व्हेन इट कम्स द वही पॉइंटर यहाँ ज्यादा आएगा. सॉरी, दिस आयरन पीस विल कम इनसाइड हियर and as much more the deflection will be as much more. Okay. If it is attraction is less, deflection is less. The deflection pointer depends upon the strength of the current and that is what the strength of the magnetic field. Okay, the current is less, magnetic field is strength is less, deflection is less. Current is more, magnetic field strength is more, deflection is more. Is that right? Okay. So the controlling and balancing weight are also shown. Controlling and balancing weight are shown. It gives the controlling torque. Okay. So the control and balancing weight are shown. The arrangement of this friction damping कौन सा है? इसमें कौन सा controlling है? Gravity control is there. And friction कौन सा है? Air friction damping is there. So if the instrument is to be used as an ammeter, the coil has a comparatively few turns. Other one. I say that this is the use for the ammeter as the voltmeter. This is very important. The same instrument is for the ammeter and voltmeter. When it is used as an ammeter, what I say, ammeter, the coil have less number of turns. ध्यान से देखो, turns of thick wire. When it is used as an ammeter, the coil is having less number of turns of thick wire. उसमें कम turns होते, but turns होते जाड़े wire के, the thickness of wire is more. Okay, so if the instrument you use the ammeter, the coil has comparatively less, a few turns of thick wire, so that the ammeter has a low resistance and allow to the flow of the maximum current, and the instrument is connected in series with the circuit. Okay, the ammeter is connected in series. It is having low resistance. It is above because there is a less number of turns. अगर इसमें ज्यादा turns रहेंगे तो what about resistance will increase. Resistance will increase. What happened? Then what happened? The current will decrease ना. Resistance बढ़ेगा तो current कम होगा. इसलिए इसका resistance कम से कम रखते हैं. Resistance कम से कम रखते हैं ताकि we can get the accurate reading of the meter. So if the instrument is to be used as an ammeter, the coil has comparatively few turns of thick wire, so that ammeter has a low resistance to allow the flow of maximum current, and the instrument is connected series with the circuit. Instrument connected, this ammeter is always connected in series with circuit. Ammeter, what is connected to ammeter? Ammeter is always connected in series. It is having less resistance, what a less resistance, okay, to pass the maximum current. Okay. If the instrument is to be used as an voltmeter, then what happens? the coil has high impedance, so it draws a small amount of current. The instrument used as a voltmeter, as a voltmeter. Instrument used as a voltmeter. Then what happened? Instrument used as a voltmeter. As that the as used as a voltmeter, the coil has high impedance, so as to draw this small current as possible. Since it is connected parallel to the circuit, the current through the coil is very small. It has a large number of turns of thick wire. It has what a when it uses the voltmeter, it has a large number of turns. Opposite, what happened? It has a large number of turns of thin wire. Ammeter has what a less number of turns of thick wire. Voltmeter has a large number of turns of thin wire. What happened? Large number of turns of thin wire. Is it right? Large number of turns of thin wire. Then when it uses ammeter, less number of turns of thick wire. Uses voltmeter, large number of turns of thin wire. Okay, necessary. So this type of the scale the scale on the field is not uniform but uneven. The meter can be used on AC and DC. What I say, this meter is used for AC and DC, and the scale is not uniform. What do you mean by scale is not uniform? See that the scale is not uniform. Scale is not uniform. Uniform मतलब क्या? आपने स्कूल में यूनिफॉर्म पहनते हैं, हम you are having this same dress, same pant, same shirt, same tie, same boot. That is called uniform. The scale is not uniform. Suppose this is the ammeter scale is there, 0 to 5 ampere, is right? So what happened? This is the 1, this is the 2, this is the 4, this is the 1, 2, 3, 4. So that is what non because the distance between 1 and 0 and 1 is more. Then compared 0 to 1 and 2 is less. The distance 0 to 1 is less, other is same. So that is what the scale is not equal. The scale is uniform is what? This is scale is uniform. 0 to 5. 1, 2, 3, 4. Then all distances are equal. That is called scale is uniform. But here scale is not uniform. Is that right? Understand? That's why this the scale is not uniform. So it is not the scale is not uniform, and this meter cannot be used for AC as well as DC. This property can be used for AC as well as DC. The errors में इसमें errors क्या होते हैं? Due to hysteresis losses, due to eddy current losses, and due to change in the resistance, due to change in the temperature. इसमें क्या क्या errors आ सकते हैं? इसमें eddy current losses हो सकते हैं, hysteresis losses हो सकते हैं, और टेम्परेचर बढ़ने से इसका ड्यू टू चेंज इन रजिस्टर, अगर टेम्परेचर फाइल गर्म हो गई तो उसका रेजिस्टेंस कम ज्यादा होगा, जिससे उसके रीडिंग में भी इफेक्ट पड़ेगा. इज राइट? सो दिस ऑल अबाउट द इंस्ट्रूमेंट. फर्स्ट ऑफ व्हाट यू डिसाइड, इट वर्क्स ऑन, it is used to measure AC and DC current. AC and DC current. Okay, the scale is not uniform. The reading is not so accurate. So in this instrument, the coil is divided into two parts. Okay, and what happened in the current to be measured is passes through this coil, and one soft turn pieces is kept near the coil. And understand what happened? Gravity control weight is attached for the controlling system, and air friction damping is connected for the damping system. But this is the construction. When current passes through the coil, this मैंने बताया this instrument have a coil divided to have a hollow coil that is divided into equal parts. One softened piece is kept near the coil. So one softened piece is kept near the coil. Gravity control system is used for the controlling system, and air friction damping is for damping system. This is the construction. What is working? When current passes through the coil, the current to be measured is passes through the coil. What happens? The magnetic field is produced. Okay, and this due to this magnetic field, the soft iron pieces attracted towards the coil, and due to that, the spindle moves. So the spindle moves, and the deflection spindle is controlled by the gravity control, and damping is controlled by the friction damping. Okay? If the current is more, the magnetic field strength is more, and then deflection is more. If the current is less, the magnetic field system, the magnetic field is less, deflection is less. So we can get the current, we can measure the current as per the strength of the current. Okay. When it is use an ammeter, it has the less number of turns of thick coil and is connected in series. When it is used as a voltmeter, it has a large number of turns of thin wire and it is connected in parallel. This is the difference, is right? This is all about the construction working of moving iron instrument diagram. Is right? Got the point? Hello? समझ में आया कि नहीं आपको?
हाँ
Only 10 boys are there today. Okay? So diagram सब लोग निकालो. निकाला आपको? This is very, very important. 100 explain the construction of moving iron instrument with the diagram and okay and explain its working. Okay, so this is the all about the moving iron instrument. आपको नोट डाउन कर रहे हो कि मैं रब करूं इसको? Can I rub it now? Hello, just draw the diagram, draw करके दो. Okay?
Done, sir.
Okay. Hello, all of you drawn this?
Yes, sir.
अच्छा मैं रब कर दूं इसको. What is your name बेटा?
Swastik, sir.
स्वस्तिक. अच्छा अच्छा. डायग्राम आता कैन आई रब इट नाउ? पुस्तक का डायग्राम
Yes,
आहे.
sir.
ओके. आता second type is that repulsion type moving iron instrument. कुठला आहे? Here you are using the attraction principle. That's why his name is what? Attraction type instrument. Now we use the principle of repulsion. That's name is what? Repulsion type instrument. Okay. Repulsion type moving iron instrument. Second is what? Repulsion type moving iron. इसमें देखो diagram देखो इसको. Repulsion type moving iron instrument. Okay. Second is repulsion type. Okay. So what happened in this case? Here is also what? इसमें क्या होता है? एक hollow soft iron piece होता है. There are two pieces there. Two pieces are there. One is the what? Two soft iron pieces are there. It kept inside the coil. One is moving and another is fixed. Two soft iron pieces. One is moving, another is what? Fixed. Understand? So just draw diagram. Okay. This is soft iron pieces. Okay. So in this, there's one spindle is there. On this spindle, we are putting the two soft pieces. एक spindle बना देते हैं. Central spindle is there. Okay. Okay. This is a diagram of what? Attract time instrument. Okay. So this is what spindle there. This is a moving iron is there. Fixed iron is kept inside what? Coil. एक coil के अंदर spindle है. उस पे spindle is connected. Gravity control is there. There air friction damping is there. Control is connected there. Simple is fixed here. This spindle is supported here. The coil है उसके अंदर spindle है. Spindle के अंदर moving iron है और fixed iron. और this gravity का W1 है. W2 gravity control. This is the pointer. This is what damping. This is the scale. This is the okay. So how it will this portion, okay. So figure shows the which has two soft iron pieces. A fixed moving iron pieces, fixed iron. Okay, two soft iron pieces. The two soft iron are these pieces are the form of the rod. This was in the form of rod. These pieces are in the form of the rod, rod of surface, the curved surface. These pieces are parallel. These two pieces are parallel to. These are in the form of rod, curved surface, and parallel to this moving iron pieces parallel to each other. Is that right? And parallel to each other. The piece A is fixed on bobbin, and fix is mounted on the fix A. This is a what I said. The fix A is a moving on fix B. Fix A. This is a A moving on part A. This is moving on part B. So the pointer moves over the. So when current passes through the coil, जब इसके अंदर coil में current pass होता है, the magnetic field is set up. क्या होता है? Magnetic field set up. Due to the magnet, the rod A and B are magnetized. इसके अंदर magnetic field होने की वजह से the rod A and B will be magnetized. इसके अंदर magnetic field जो आएगा, magnetic lines of force ऐसा क्या होगा? And rod and A and B get magnetized. The rod A and when current passes through the coil, the magnetic field is set up. Due to the magnetic field, the rod A and B get magnetized. With the same, we get the magnetized rod A and B get magnetized with the same polarity. Rod A and B magnetized with the same polarity. With the same polarities. With the same polarity, right? And they then अगर उनमें same polarity हो तो क्या repulsion, they repel with repel with and repel with each other and repel with each other. Each other. Repulsion force will produce that they repel with each other. Then what happened? The repulsion force on the same polarity will repel each other movable. The B moves and hence the spindle and pointer deflect. What happened? The pointer B are magnetized with the same polarity. They repel each other and movable. B moves and hence the spindle and pointer gets deflected. B moves. Okay. इसमें रिपल्शन फोर्स होने से क्या होता है? This is the fix है और one is the move. B, which is first I will determine which is A and which is B. Once again, once I explain this is the same polarity. If one of the A is fixed on at the bottom, B is movable. Sorry, A is the fix. A is the bottom, B is the movable. B is the movable. Okay, A is the fix at the bottom, B is the movable. तो fix मूव नहीं होगा. रिपल्शन फोर्स होने से जो मूवेबल है वो फोर्स होगा, जिसको पकड़ के रखा है वो मूवेबल है, बट जिसमें जो फ्री है दैट विल वाइब्रेट अप when current is to the coil is set up. Due to the magnetic field, the rod A and B are magnetized in polarity. They repel each other and move. Repel each other and movable. B moves. कौन सा coil move होगा? Moving coil moves होगा. B moves and hence the spindle and pointer gets deflected. Move नहीं होगा. कौन सा होगा? जो coil है, moving iron disc वो move होगा. And move होगा. इसमें क्या है? स्पिंडल एंड पॉइंटर जो स्पिंडल इसके साथ अटैच है, ये जब ये मूव होगा ऐसा तो क्या होगा? स्पिंडल मूव होगा तो स्पिंडल राइट, स्पिंडल मूव होगा तो पॉइंटर मूव होगा. 1 मिनट. listen here, sorry. So what happened? Fixed and if A is fixed, B is movable. So when this B rod moves, then what happens? The spindle moves and pointer, right? So and get the deflected. The force of repulsion and therefore of the pointer is approximately proportional to the square of the current. The deflection of pointer is proportional to what? Square of the current. Deflection of pointer is very important. Deflection of pointer is proportional to square of the current. Okay, deflection of pointer is proportional to what? Okay, the current to the coil. The scale is therefore the scale is uneven. The scale is what? Scale is uneven. Not uniform. The scale is uneven. Okay, and the gravity control and spring control. इसको कौन सा use करते हैं? Gravity control, spring control is for control system. Air fraction is for the damping. इसमें कौन सा use करते हैं? Gravity control और spring control use करते हैं for controlling system, and air friction damping is used for it. Okay, such instruments widely used. They are cheap. They are ज़्यादा से ज़्यादा this time करते हैं. Repulsion use करते हैं. These are widely used. Widely used. Widely used. This is the cheaper. Widely used. It is cheaper. Okay. Okay. They are widely used rebar and can AC and DC, and this is the more accurate. It is more accurate than attraction type. It is what? More accurate than repulsion attraction type. More accurate than attraction type. More accurate than attraction type. Is it right? Is a more accurate than attraction. समझ में आया? So what we studied? Now we studied two types of the instrument. Two types of instrument. So what? Type moving iron instrument and repulsion type moving iron instrument. Is right? There we are using what? Attraction principle. I am using what? A repulsion instrument. So in that case, one soft piece of iron is free to move two pieces of the what? Coil. Soft is kept open, attracted when the current passes through the coil. That more current, more attraction, less current, more attraction. The spindle moves, pointer moves. Here we are having the what? One coil is there. In that hollow, we are keeping two soft iron pieces which is parallel to each other. Okay, one is to the coil, other is what? Free to rotate. Okay, when current passes to this, the same polarity produced in both the two soft iron pieces repel each other. Okay, so one is fixed, other is movable. The B rod is moved, and when the B moving rod is moved, what the pointer moves and different, then spindle moves and then pointer moves and will get the reading. And the deflecting force is controlled by the gravity weight. Controlling system is given by the gravity weight control, and damping system is given by the air friction damping. Understand? This is the more accurate. This is the widely used, cheaper, and the scale. This is all about the first repulsion type instrument. Is that right? Understand? So after that, next instrument is permanent coil instrument. We'll see next period. That is used for the only DC and DC current. Then we'll differentiate between moving iron and moving coil में क्या differentiate होता है वो हम लोग देखेंगे. Is that right? Okay. Any doubt? You have to come for the practice for next Wednesday and Thursday, 119 and 20 to the hours. You got the timetable? So any doubt?
No, sir, no.
पहले first then to date. Okay, सर ने बताया आपको. Okay. Okay. ठीक है. आई विल शो यू पेपर इमीडिएटली एट द टाइम ऑफ प्रैक्टिकल एग्जाम. प्रैक्टिकल एग्जाम होगा तो आपको मैं पेपर दिखाता हूँ.
Yes, sir.
Okay, have a good day.